guys, welcome back to TechDose, and in this video we will look at the sliding puzzle problem which is from Leetcode number 773. Let's now look at the problem statement. In this problem we are given a 2x3 board. There are 5 tiles labeled from 1 to 5 and an empty square represented by 0. A move consists of choosing 0 and a 4 directionally adjacent number and swapping it. The state of the board is solved if and only if the board is 123, 450. Given the puzzle board, return the least number of moves required so that the state of the board is solved, and if it is impossible for the state of the board to be solved, then we need to return -1. In this case, if you look at the constraints, then the board size is exactly fixed to a size of 2x3. So it is a constant size board, and all the values are unique, and it will always be from 0 to 5, where 0 is denoting the empty space. Now let's look at an example for better understanding. In this case, we are given a state, and from this state we have to go to a final state, where the final state consists of all the numbers 1, 2, 3, 4, 5, and 0 will be at the last cell. So in this case we need to find the minimum moves to reach to the final state from our given state. Only 4 directional adjacent swaps are allowed. So if 0 is present here, then you could have chosen any of the 4 directions to swap, but then if you look at it, the up swap is not possible because it will go out of bounds. So you can swap with either 3 or 2 or 1, right, and go to the next state. So if you do that, if you do your first step, then the optimal swap will be move 0 here and move 2 here, and then you swap it with 5, so move 5 here and move 0 here. So in 2 swaps you are actually able to reach to the final state. If you go for any other strategy, any other movement, then you will not be able to do in less number of swaps, right? So in this case 2 is the answer. So the steps are swap 0 with 2 and then swap 0 with 5. That is what we did. So I hope the problem statement is clear. Now in order to solve this, we will look at some observations. The first observation is we will convert the 2x3 grid into a 6 size string. This is called flattening, and we will flatten it for easier comparison of the state, and the state transitions will be easier as well. You will understand it by the end of the solution. So we are just traversing row wise. So first you traverse the first row, then the second row, and just flatten it in the form of a string. Okay, so this is the flattened string. So this is, let's say, your current state, and you will always be having the flattened string for the final state, which will be 1, 2, 3, 4, 5, 0. This will always be the final state. Okay, so our goal is to transition from the current state to the final state, right? Another observation is we are allowed 4 directional movement. So if you look at it, if the 0 is present, which is an empty space, then I can slide it in any of the 4 directions. Definitely the up sliding is not possible, it will go out of bound. So currently our state is 103. If you look at it from left to right, 103 and then 4 to 5. So this is what is given, 103, 4 to 5. Now if you look at all the possible transitions for this 0, then it can be swapped with this 1. So if you swap it with 1, then what happens is the string will change to 0, 1, 3 and 4 to 5. So you see there 0, 1, 3, 4 to 5, right? If you swap it with the right hand side, then the string will be 1, 3, 0, 4 to 5. You see here 1, 3, 0, 4 to 5. And if you swap this 0 with this 2, then your string will be 1, 2, 3, 4, 0, 5. So you see here 1, 2, 3, 4, 0, 5, right? So this is how the state transitions will happen by swapping this 0, and definitely we have to try out all possible transitions and find out the one with the minimum cost. That means the shortest path, right? So let's say that this was our current state, and from here I am trying to find out what are all the possible swaps. Now in this case, if the 0 is present in the top left corner, you can swap only with the right adjacent item and the lower adjacent item, because top and left calls are not possible. So which positions in the string are we swapping with? If you look at it, 0 is swapped with 1 or 5. So 1 or 5, where are they present? At index 1 or 3. So I can say that if 0 is present at the top left corner, that means index 0, 0, or you can say if 0 is present at index 0 in the flattened string, then we can swap it with the index 1 or 3 in the same flattened string. Okay. Now let's look at the second position of 0. For this 0 position, I can swap it with 1, 3 and 2 in the flattened string. What are their location? At index 0, 2 and 4. So I'll record the possible swapping positions if 0 is present at index number 1 in the flattened string. Similarly, if 0 is present at index 2 in the flattened string, I can swap it with 3 and 4. The position of 3 and 4 are 1 and 5. So I will just record the position 1 comma 5. In the same way, if 0 is present at index 3 in the flattened string, that means it is present in the bottom left corner, it can be swapped with 1 and 2, and the position for it is 0 and 4. So I will record the possible swap positions if 0 is present at index 3. Similarly, you can find if 0 is present at index 4, then the possible transitions will be this one is index 1, you see, this one is index 3, and this one is index 5. So I will say 1, 3 and 5 as the possible swap positions. If 0 is present at 5, then I can swap it with this 5 or 4, that means index 2 or 4. So I'll record this position as well as index 2 and 4, right? Now we know that depending on the position of 0, we can make the transition in all of these possible states by doing all of these possible transitions, right? So these 1 comma 3, let's say, what is this 1 comma 3 meaning? It means that if 0 is present at this top left corner, that means at index number 0, then I can go to new states, and the new states can be, if I happen to swap it with the first position, that means index number 1, then the new state will be 1 0 3 5 2 4. This is done by swapping this 0 and 1. And I will also try out the other possibility, that means what if this 0 was swapped with this index 3, that means 5. Then in this case, the new state will be 5 1 3 0 2 4, right? So that is why I am storing all possible swap positions that you can have, which will actually define, being at a current state, what all next state can you go to actually, right? So I hope this makes sense. Now, having known this, what we are trying to do is state transition. So if you consider the state transition, then there will be certain start state which will always be given in the input. So this is already the input puzzle. So if you flatten the input puzzle, it will be the start position, right? You can consider it as the source. From here you will do certain combination of transitions, that means sliding, and finally you will be able to reach to the destination, right? So this is the final state, and this is always 1 2 3 4 5 0, right? In the flattened string, you know, this is what this is where you want to go, right? It may not be always possible to reach this destination. In that case you have to return -1, but if it is possible, I want to find out the minimum number of hops in which you can reach here. So if you look at it, one possible way could be doing here 1 hop, going to S4 in the second hop, going to S2 in the third hop, going to S5 in the fourth hop, then going here in the fifth hop, and going here in the sixth hop. So you can reach from S1 to S7, which is the destination, from source to destination, in 6 hops. So this is one way to reach, right? But then there are other ways to reach as well, and the shortest way is by using 3 hops only. This is 1, 2 and 3 hops, right? So in this case, out of all the possibilities, we have to return the shortest path, and that is why we will be returning 3 in this case, right? In this case, if you are wondering what are the edges are actually denoting the swap, because being in a particular state, let's say 1 0 or 1 0 2 3 4 5, then in this case, if this 0 is getting swapped with certain value, then only we move to a new state, right? So if this 0 is swapped with this one, you go to 0 1 2 3 4 5, and this may be called as state 2, but then there may be other possibilities as well. So those all will be added to the adjacent list of this S1, right? So this is how you build the graph. Now once you have the graph, you know you are going to find the shortest path from the given source to destination, right? Now what are the shortest path algorithms? One algorithm is the Dijkstra algorithm, which is single source shortest path. But Dijkstra uses BFS plus your heap, which is priority queue in C++, right? So it uses BFS plus heap. In this case, all the hops are of equal cost. They are not a variable cost, right? So we do not need this heap. Instead, we can just go for BFS, which is level order traversal, where I will be counting how many levels have we actually traversed in order to reach to the destination. And the first time I reach to the destination in the level order traversal, that will be the result, isn't it? That will always be optimal answer. So in this case, since all the costs are same, we do not need a heap, and so simple BFS we have to apply. Now let's look at a dry run in order to understand this. Now we will be trying to find the shortest path from the given state to the final state. So in this given state, we will be converting the puzzle in the flattened form. That means 1 0 3 4 2 5 in the form of a string. What is our final state? Our final state is to reach 1 2 3 4 5 0, where the 0 comes in the bottom right corner, right? So when we are about to start this, then we will take level value, which is used for the level order traversal. The level value will be 0 initially because the given state may be equals to the final state. Okay, and then we do not require any transition to be done. So in that case, we have to return 0. That is why the level is starting with 0. In order to start BFS, we have to insert this initial state into the queue that we have done, and we have to also mark this as visited. So our visited set will maintain that the same state is not processed again and again. Okay, so this is done for optimality. Now, once we are done with this, we know what is the position of 0. The position of 0 is at index 1. Okay, so from index 1, where you can do the swaps. If you remember, I can do the swap from this 0 to the left hand side or right hand side or down, right? What is this index? If you flatten it, it is index number 0. What is this index? Index number 2. And this index number 4. Now let's start processing. First thing, we will find the size of the queue that will give me level number 0. And then you pop it out. So this is my current state. From here, I will try to do all possible state transition. Now we will do our first swap and try to do a state transition. If you do that, you will be reaching to 0, 1, 3, 4, 2, 5. This is the new state. Now you have to check that if it is already visited, you see that it is not visited. That is why you will mark it as visited 0, 1, 3, 4, 2, 5. And we will be inserting it into the queue 0, 1, 3, 4, 2, 5. Okay. This is the first state transition. Then another state transition could be swap this 0 with 3. And if you do that, the new state will be 1, 3, 0, 4, 2, 5. You check this. Is it already visited? It is not visited. So that is why I will be saving it in the queue 130, 4, 2, 5. And I will be marking it as visited. Fine. Now another state transition could have been swap this 0 with 2. And if you do that, then you will go to the new state as 1, 2, 3, 4, 0, 5. Now this is also not visited 1, 2, 3, 4, 0, 5. So I'll be saving it into the visited set, and I'll be saving it in the queue as well 1, 2, 3, 4, 0, 5. Okay. So all the state transitions are done for this, and now we are done with level 0 as well because we just had one item, right? So I'll be doing level plus plus. And I'll be finding for the next level how many items do I have. These all are belonging to level number 1. Now I will be popping out each of the numbers one by one, and I'll try to do all possible swaps. So if you see this 0, 1, 3, 4, 2, 5, what is the state? 0, 1, 3, 4, 2, 5. Fine. If this is the state, then you know that 0 has two possible swaps here, right? So you pop it out and you try to do these two possible swaps. If this 0 and 1 are swapped, then the number will become 1, 0, 3, 4, 2, 5, isn't it? 1, 0, 3, 4, 2, 5. You check it out. Is this state already present? 1, 0, 3, 4, 2, 5. So this is already visited. So we cannot go to this state. Another state transition is swapping this 0 with 4, and that will make it 4, 1, 3, 0, 2, 5, right? Check it out. Is it visited? No, it is not visited. So mark it as visited 4, 1, 3, 0, 2, 5, and we have to insert it 4, 1, 3, 0, 2, 5. Inserted. And we are done with this transition. Take out the next node 130, 4, 2, 5. What is this? If you think 130, 4, 2, 5. Okay, this is the puzzle. Now this 0 can be swapped with this 3 and 5. If you swap this 0 with this 3, then what will you find? You will find 103, 4, 2, 5. You see this 103, 4, 2, 5 is already visited, so I will not process it again. Swap this 0 with 5, and that will make it 1, 3, 5, 4, 2, 0. Now if you check it out, this 1, 3, 5, 4, 2, 0 has not been visited, so you can mark it 1, 3, 5, 4, 2, 0, and you can save it here 135, 4, 2, 0. Okay, so we are done with this state transition as well. Now we will be taking out the next option 123, 4, 0, 5. So what is this? 123, 4, 0, 5. In this case, this 0 can be swapped with this 2, 4 or 5, right? If you swap it with 2, then the state will be 103, 4, 2, 5. You see this 103, 4, 2, 5 is already traversed, right? So I will not be considering this option. If you consider swapping this 0 with 4, then the new state will be 1, 2, 3, 0, 4, 5. Right, so 1, 2, 3, 0, 4, 5 here. Has it been traversed? 1, 2, 3 is here, but then 0, 4, 5 is not present. So maybe I'll be inserting it 1, 2, 3, 0, 4, 5. And I'll be inserting it here as well 1, 2, 3, 0, 4, 5. Fine. So this is the new state which has been inserted. Okay, then the next state would be swap this 0 with 5, and then it will be 1 2 3 4 5 0. So this is also not traversed, so you can just traverse it 1 2 3 4 5 0. Now you can stop here because this is the target, but I will stop only when I pop the item and check it always with the target, right? So that is how I will be doing it. Now I will be inserting this, and I'll also be saving 1 2 3 4 5 0. Okay, fine. Okay, so we are done with this. Now at the next level we will be marking it as level number 2, and I'll be doing level plus plus, right? So again, this level has 4 different states to be processed, so we can process each of the state one by one. I will show you just one, and then I will show you that this already has an answer, right? So in this case 413045 will be picked up. 4130 yeah, 025 is picked up, right? Now this 0 can be swapped with this 4, and the new state will be 013425, right? So is it already present? You check it out. 013425 is already present, so this state cannot be done. Now if you try swapping this 0 with 2, then you will have 413205. Okay, is this present? 413205? No, it is not present, so I have to insert it 413205. Okay, and I have to insert it here as well, 413205. And so we are done processing this node. If you keep processing these nodes, you will be processing this node as well. But then as soon as you see the destination node, you will be returning the level as an answer, and in this case 2 will be the answer, right? So I hope you have understood how this shortest path algorithm is working. Now if you are not able to reach to the final state and your queue becomes empty, then we will be returning -1, meaning that we cannot reach from the given initial state to the final state. So in this case the total number of combinations is mn factorial. What is mn? Mn is the total number of nodes, which is 2 into 3 in this case, which is fixed, right? So the total number of combination is the permutation of all these numbers, and you know permutation is whatever is n, you take n factorial. That is the permutation of n numbers. So here you have total mn number of items, so the permutation of it will be mn factorial. And then for each of these permutations, whatever is the value, let's say the state was 123045, then I have to iterate and find out the index of 0, right? Because that is how I will be trying out what will be the next possible sliding option. So finding out this 0 position will be mn time, where mn is the string size, right? So in this case this mn is added for finding the position of 0 that will actually determine what are the possible options and index of swap. So that is why the time complexity is mn factorial into mn. And if you think about the space complexity, then each of these permutation will be consuming certain space. So you know how many combinations you have mn factorial combination, and so each of them will be consuming mn space too, because each of the string length will be of size mn. So you can just multiply them, mn factorial into mn, and that will be the space complexity. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code we are given the board, and then I'll be taking the current state. So extract the current state and flatten it in the form of a string, and I already know what is the target state, so I can just hard code it. After this I will be trying to apply BFS. So I'll be taking a queue which will always store the state, and I'll be taking a visited set which will be marking what all strings have already been visited, so that already visited states will not be visited again. Then initial state will be inserted into the visited set, and I want to make 4 directional calls. So this I had already explained why I have written all these values, right? It depends on the 0 position what will actually determine or what are the actual options for you to swap, because if 0 is present here, then these are the indices where you can swap, right? So these are the indices in the flattened string. Now since I want to apply BFS and count the levels, I want to do level order traversal. I'll be counting the levels here, and then I will be trying to apply the level order traversal. Let me show you. In this case I'll be just doing the simple level order traversal, where I'll be finding the size of the current queue, and that will determine the total number of items at a level, and I will be processing those many nodes. So I'll be taking the front, which will be the current state, and then if the current state is equals to target state, then the number of levels is my answer. If it is not, then I'll find the 0 position, as I said, and once you have determined the position of 0, then this directions will actually tell you what are the possible swap positions. Like if 0 position was, let's say, at index 0, right here you had a 0, then you can do a swap on the right and left. If you think it like a flattened string, this is index 1, 2, 3, 4, 5. So you can swap this 0 with index 1 and 3, and that is why we have 1 and 3 value here, right? So I think that makes sense. So that is why I am finding the 0 position. Once you have found that, then I will be iterating for all possible positions with which I can do the swap, and I will always be calculating the new state by doing the swap. And if the new state is not visited, then I will mark it as visited and insert it into the queue. And finally, after processing this entire level, I will do level plus plus, and if I could not find the final state even after processing all the states, then I will be returning -1, saying that I cannot reach the final state. So this is my entire code, and I hope you are able to understand it. If you still have any doubt, then feel free to comment below, and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.